I'm using the participation assignment from my March 23rd pre-calculus lesson to talk to my 302 students about good feedback. So what I gave these pre-calc students for a ticket out for their participation assignment is equivalent to what you might give as a ticket out the door as a high school teacher. So let me read from the EdTPA. One of the things that the EdTPA asks you to do is when you write your EdTPA, you're going to submit 3 student work samples. And you have to explain how the feedback provided to each of those students addresses their individual strengths and needs relative to the learning objectives. Then another question asks you to describe how you will support each focus student to understand and use this feedback to further their learning related to learning objectives, either within the learning segment or at a later time. And I think this is a really difficult question. And this is one that I know I'm not fantastic at in my own teaching. I'll mark things right or wrong. I'll give them back to them. They'll stuff them in their binder and move on. All right. So that is a really important question, is how do we help students use the feedback that we give them to further their learning? Okay. So just saying to them, well, that's wrong. Okay, that only tells them so much. How does that further their learning, right? Or if we say to them, well, don't do this instead. That only helps them with that specific skill right in that moment of time and doesn't really advance their skills as a mathematician. So let's talk about how I might have given some really good feedback to a student who struggled with this problem. All right, so first of all, let's say the student didn't know the domain and range. Okay, the first thing that I would say to them is, can you draw an accurate graph? All right, that would be the first issue that I might address with identifying the domain. All right, and so then I might say to the student, well, is the domain the X values or the Y values? And as long as the student has an understanding that, okay, it's the X values, then I might take them along the X-axis and say, well, tell me, as I move along this X-axis, tell me if all of these X values can be input into the function, right? Based on the graph that I drew, right? So if they know that this is the graph, then and they understand how to connect graphical representation with what can be input, they may or may not know how to connect those two concepts, then they might be able to see that the domain is all real numbers. Now, one of the things that I said in my video, and this is where it puts a lot of pressure on me to have to improve my own teaching when I know that I'm doing things for education students who know more than my typical math students know. So one of the things that I had talked about in the video to help support them in general, right? So a general support that I give for domain is I talk about how we can input anything that doesn't give me a 0 in the denominator or a negative under the radical. So that is true. When I make that statement, I do have to be careful because that is true only for algebraic functions, which is all we had been working with at that point in time in that class. So that is something we do have to watch out for as teachers, and I get guilty of it myself, where we make a generalization about something that's true in our limited view of what we're doing, and then they might get to a more advanced topic or the next class and find out that what they had were told that was a hard, fast generalization might not always be true. So that's definitely something when I say what should I have improved in that video, I should have been very careful to specify that when I tell them the domain, the input is what I can input anything that doesn't give me a 0 in the denominator, doesn't give me a negative under the radical. I should have distinguished that that's only true for algebraic functions. But again, I would refer to that as a planned support. So when we talk about how do we support our students in domain, using domain, graphical representation is a planned support, right? How to identify a domain from a graph, right? By highlighting along the x-axis. That would be a planned support. But my other planned support then was telling them, watch out for zeros in the denominator, watch out for negatives under the radical. Those are the things that give us a problem. So that's a planned support to try to make a generalization about domain that applies across a whole bunch of different functions, right? That's very accurate until we start running into exponential and some of the transcendental functions. Then I have other restrictions for domain besides just the two cases that I've given them. So anyway, let's suppose that the student couldn't even do the graph. Okay, so they couldn't even draw a rough graph, and then obviously you're not going to state the domain and range in that case. So let's talk about how else I could have given them feedback. So in general, when it comes to determining the domain, the input, all right, if I were to think about categories of numbers, okay, so if we think about our real number line, and I divided this into 0, right? Because sometimes 0 is one of those numbers that has special characteristics in certain cases. Then we have our positive numbers. We have our negative numbers. And then within the positive numbers, I'm also going to distinguish from two branches of positive numbers where we talk about greater than 1. That's a less than. Oops, I meant greater than. Greater than 1, so numbers greater than 1, or numbers between 0 and 1. So I'll just put a there for the number. All right, so those are different branches that we would want to consider. So I would start talking to the student, well, what kinds of things can I input, right? Domain is input. So I would ask them, can I input positive numbers? What would happen if I input a number like 2, right? Would I get an output? Sure. And if I input 2, I get an output of 25, right? And then I'd be asking them, now pay attention to what kind of outputs you're getting, because that's how going to help you figure out range, right? So maybe I'd encourage them to write a table of values, but then they need to consider all these different cases. All right, so what I'm doing is when I'm giving them this type of feedback, I'm helping them not just in the moment with this problem, but how they could figure out range and domain for any function, right? Not just, this is not just specific to exponential functions. And so in my opinion, that's the type of feedback that we need to give students that will really advance their learning. Because what I'm teaching the student here is to be self-sufficient. All right, because otherwise I would say to the student, well, memorize it, right? Domains all reals, ranges 0 to infinity, just memorize that, right? But I'm teaching them how to reason through it, be self-sufficient. You know, what are you going to do if you forget, right? When we memorize things, we forget. But in this case, I'm helping the student to go through a series of steps and also reason and problem solve, and use this series of steps that will work for any range and domain problem that they ever might encounter. And if they carry out this series of steps, then this is going to help them in future mathematics, not just in the moment with this one particular example. All right, so that's what I think. That's how I interpret really good feedback. So anyway, I'm telling the students, keep track of what you're getting for output, because that's going to help you determine the range. All right, and so then I would say to the student, okay, we can do positives. What if I input a fraction, right? Could I input a half? And if I did, what would happen, right? And so a half, they should recognize that that would take the square root. All right, I would be taking the square root of 5, or if I input a third, right, that's the cubed root of 5. So yes, I can take the square root of 5 and the cubed root of 5. Okay, square root of 5 is like 2 something. cubed root of 5. I don't know that off the top of my head, but like 1 something. And so I can ask them, okay, what types of input are you getting or output are you getting? Okay, so you did get a positive answer. So notice my answer is positive, right? Square root of 5 is about, 2 something. Okay, so I'm getting positive output. I'm not necessarily just getting whole number answers, right? Radical 5 is irrational. That would be the output I would get. Okay, I'd ask them to input 0, right? I'd get 1 as output. And then I'd say to them, well, what if you input negatives, right? Let's input -2. Okay, the student could do that and hopefully know that that's 1/25. Okay, so notice I am getting an output of values that are less than 1. And then I would point out to the student, okay, I get whole number output, I get irrational numbers as output. Here I've got this fraction, which is less than 1. That's my output. Could I get a negative output, right? If I continue to input, negative values for x, right, would I ever get negative output? Right, and so again, if the student tries more of these, right, I'm never getting any output that's negative. I'm also never getting an output of 0, right? So I might ask them, well, is there any way I could raise 5? Could I get 0 as an output? Is there any way I could raise 5 to some power and get 0? Right? I wouldn't be surprised if they said 1 because they'd mix up that 5 to the 0 is 1, but those would be the kinds of things that I would ask them to consider. And so hopefully they could take all of this information, put this together, and recognize that the range would be not including 0, but on to infinity, right, with all numbers in between. So let me erase some of this. So on your EdTPA, it's, you have to write feedback on the test. And so could I really have all this feedback on my exam, right? And that's not necessarily realistic, right, to go through all of this feedback on the exam, write all this feedback on the exam. But what I would do is for my EdTPA, I would show some of the advancing questions. Like I would say things on the test like, try plugging in negatives, 0, positives, and then both numbers between 0 and 1 and greater than 1 and see what kind of outputs you get. I might write that on the test. All right, but then part of the EdTPA says, describe how you will support each focused student to understand the feedback at a later time. All right, so then I would talk about how after I had written that advancing question on their test, how I would bring them in, during their AIS session or after school, and I would sit down with them and I would go through the steps here that I just outlined. All right, and if I described that in detail, that should score very well on the EdTPA assignment. Now, notice that I took out question 2 from what I had actually asked the students. So question 2 was actually a scaffolding question, because I had on question 2 asked the students to find the inverse of an exponential function. All right, and that actually really, when you do that exercise right before you change to having to manipulate an expression with logs, that really does help that understanding, because we should know inverse switches x and y. Right, so nobody, I'm sure, has any trouble doing this. This is easy. But then I remind students, well, when we work with any equation, we want something in the form of y equals. All right, and so one of the things that I do to help students with problems like these to get to the correct answer, to develop procedural fluency, is I always remind them that in a log equation, the answer is the exponent. All right, and so that would be a phrase I would repeat over and over again. The answer is the exponent. And I would call that a planned support, right? I would try to beat that into their head, okay? The answer is the exponent. But what happens when the students forget that? Okay, so again, we memorize things, we forget things. really good feedback helps students when they're sitting there alone on the test and no one's there to help them. If they have been given the type of feedback that teaches them to be a thinker and try to work from facts that they know and advance the facts that they know into the facts that they need. If we can teach our students to do that by giving them good feedback, then that's what really the ultimate goal of good teaching is. So anyway, if I could get my students to recall, right, that exponents and logs are inverses of one another. Right? So if a student was totally stuck on this and they said, okay, so again, if my student couldn't do this problem at all, right? They left it blank. All right. And then I had to sit down with them, and instead of just saying, well, you know, the exponent's the answer. Okay, this goes here, and ta-da. All right. So instead of doing that, what could I do? What steps, what scaffolding questions and advancing questions could I ask them to do? All right, so the first thing I would do if the student came in and they had left this blank is I would say to them, can you write down for me an exponential equation, right? Write down any exponential equation, right? Because exponential equations are the inverse of this log equation. And if I know if I understand the parts of the exponential equation, I will understand the parts of the log equation. All right, so that's what I would say to the students. Now, suppose the student sat down, hopefully they would write this, right? But they might not. I might say, write an exponential equation, and they would write that, right? That wouldn't surprise me at all. This is part of why I had that compare and contrast section on the lesson, where the students were being asked to identify the difference between a power function and an exponential function. All right, so I would have the discussion with the students. Okay, that's, you know, why is that called a power function, right? If I have an exponential function, where is the variable in that? All right, so then I would lead them here. So we'd erase this. All right, and then I would ask them, okay, find the inverse. All right, I know the inverse of this is a log. Okay, I know that the normal thing to do is have an equation in the form of y equals. All right, so I know from here, I've got to get to here somehow. Okay, and so all I'm left to try to remember is what's the little number, and then what's the number that goes right here. Okay, so I know that the y has to go over here, right, because it's just normal to, you know, solve any equation for y equals. And to me, it kind of makes sense, like what, you know, the base should be this. I could even come up with some sort of language support. Like I could say to them, well, if you're in cheerleading and you're the base of the pyramid, what are you, right? The base is the bottom, right? The base is what supports the rest of it. All right, so that might help me remember that the base should be this number here, like at the bottom. Okay, and so I would call that a language support. And then by process of elimination, if the 5 goes here and the y goes here, then my x has got to go here. Okay, so then I would tell the students, okay, let's recognize the structure in repeated reasoning. Right? If I know that this is how I write a log equation, and then I get this, right, which looks a little bit different, but I know this answer over here is the exponent, right? The 27 is my base, right? So from this equation and this equation, I have to help the students see that they have the same structure, which again, helping students recognize the structure in repeated reasoning is another form of giving them good feedback that will advance them in the future. So let's see, the exponent is the answer, right? And so I would need to help them recognize the similarities between this equation, this set of equations here, and this set of equations here. Help them recognize that they're in the same, that they have the same structure. And again, that would be a form of good feedback.